Yeah, and I'm Deacon. Thanks, Spencer and Isaac, for doing your intros. Um, I was one of the first members of RaidGuild. Uh, also a super fan of Moloch and the Moloch contracts. Not Moloch, but the Moloch DAO contracts. And so yeah, excited to share a little bit with you guys what we're doing. Again, for the people who just hopped in, this is going to be talking about Solidity, smart contracts, Ethereum. No like huge prerequisites. You don't need to be an expert on any of that, but having a little bit of knowledge might be good. If not, it might be interesting to listen anyways. So I'm going to just start off with a little context. And so how did we get to MolochV3 that we're going to be talking about in a little bit? Or the Baal, codename Baal, who Baal is another name for Moloch, and Moloch is the Canaanite god of child sacrifice. But the meme has come to mean that Moloch is kind of this god of coordination failure. Won't get into the meme. We're going to say pretty technical here. So Moloch V1 started off, launched in 2018, I think. A simple DAO contract that allowed an idea of members, an idea of voting, and of like kind of weighted governance through shares. Proposals. There's also a treasury, right? And so in Moloch V1, it was just a single token in the treasury, and the proposals were able to give away shares, and that's it. You couldn't make a proposal to like send funds from the treasury. You could only make a proposal to give someone more shares. And that's where this idea of rage quit came in, which was when you rage quit from the DAO, you would get some portion, your fair share of whatever's in the treasury. So if there was 100 members and you each had one share each, and in the treasury there was 100 WETH, if you rage quit your one share, you would get one WETH back. So that was V1. Super simple, but a few limitations, right? We have no way to do these direct proposals. Anytime you're giving a grant to someone, you're actually just giving them shares in the DAO. So what happened in like the original Moloch DAO was that you would give a grant to someone, say you wanted to give them some amount of your token of WETH, you would actually give them the amount of shares that would equal to that amount in rage quit. And so once the proposal passed and their grant was accepted, they would just rage quit their shares. So V2 will address this and a couple other things. It got a little more complex. At that point, we added the ability to have multiple tokens in the treasury. So before it was only one. Now we could have any ERC20 in the treasury. There's the ability now to make a proposal directly to a person with some of those tokens. So instead of giving them shares and them having to rage quit, they would get some amount of tokens. Inside the Moloch V2 contracts have the pull pattern, which you guys might have noticed if you've received a grant or any funding or done a rage quit. So there's an internal balance basically where any funds that are sent to an address needs to be withdrawn. That's good in some ways for UX, bad in a lot of ways for UX, having to go and withdraw your funds. But it being an explicit action is also kind of good, knowing that you just received some funds from a DAO. On a interface side, it's made V2 kind of tricky because any contract, like integrating with another contract interface, if you send some funds to it, that contract needs to have the ability to also withdraw the funds from the internal balance in the Moloch DAO contract. So there has been a few mistakes where funds have gotten locked up because they've been sent to another contract, another DAO, another there's been a couple different things where they've been like kind of stuck forever. Yeah, so some of the other things that we added here was, let's see. Well, those are the main things, I guess, is the ability to make these proposals directly to people and to have multiple tokens in the treasury. A couple just definition things, which for you guys that have been playing with it just through the RaidGuild cohort, you've probably seen some of these things. Is there's an idea of shares. That's your voting voice. That's your governance power. There's an idea of loot shares, which is purely economic. You don't have any extra like being able to vote specifically on proposals, but you do have the rights to rage quit. So the shares have the rights to rage quit and to vote. Loot doesn't have the right to rage quit. I'm sorry, loot has the right to rage quit, but not to vote. You can, as a member, you may have a mix of those. You may have like 10 voting shares and 100 loot, or there's different combinations of things that can happen there. Mainly that's used for people that want exposure to a DAO treasury, but for whatever reason, either don't want to have the governance power, kind of ops side of things, or the governance team don't want them to have that kind of power. Maybe they have a huge investment into the DAO, which they should be able to rage quit. But if that investment equated exactly over to shares for voting, they would be a whale, like a super majority, and it would break the DAO. So those are some of the things we use loot for. Whitelisting tokens, everything in MolochV3, every token that is accepted needs to be whitelisted. The main reason for that is because of rage quit. It's up to the DAO to kind of like confirm that an ERC20 token is valid and safe for doing rage quit. You can jam a lot of crap into an ERC20 and a lot of malicious stuff too. So really, when you're dealing with these kind of automated transfers of ERC20s and multiple at a time, you have to be careful not to have one bad one that could kind of lock up the entire treasury. So that's why we have to have these whitelist proposals, and that whitelist's one of the tokens that can be in the treasury. And then I've kind of talked about rage quit, right? Rage quit is being able to exit the DAO with whatever's in that main treasury. You get your fair share depending on your total loot and shares, right? And it's a pretty important idea. The game mechanic there is that a proposal is made, everyone votes on it. If you didn't vote yes on that proposal, then during its grace period, which is kind of this like cool down period after a proposal passes or fails, if the proposal passes during that grace period, you can still quit and take all your money out before that proposal is enacted, which may dilute your position by giving more shares, or may dilute the treasury by giving out some funds in the treasury. So no matter what in Moloch DAOs, you always have that window. Even unless you vote yes on the proposal, then you're forfeiting your right to leave because you voted yes. But if you don't vote or you vote no, you always have that grace period, your chance to escape. And then so it's in there as a minority protection, against a whale or someone with supermajority or whatever. If they're trying to steal the funds, if there's some kind of attack on the DAO, there's always going to be that window for you to get out. The other thing is rage kick. This is where all the DAO members can decide to kick someone out of the DAO. And so when they get kicked, they're not actually being like totally removed from the DAO. They're actually just, their shares are turning into loot. So if you remember, loot has no voice in the DAO, but they still have their fair share of whatever of the treasury. The members don't get to decide that someone just doesn't get their money anymore. The person still has the right to their money, and then so they can rage quit at any time. They could just stay in, but once someone has been rage kicked, then they have the option to rage quit, or at that point, the DAO can actually just be like, we don't want you around anymore. Take your money and leave. We don't want you even sitting on our DAO as a loot holder. So that's when rage kick. Sorry, I think I messed that up. So guild kick is the first step, and then rage kick is the second step of actually forcing that rage quit, forcing the person to do a rage quit. So there's a lot of memetic kind of terms in all of this, and but that's kind of the context of how all this happened. And starting off super simple, getting a little more complex, and now we're going into MolochV3, which changes everything up again. But it continues to have some of these ideas like rage quit comes along. So that's kind of the context of V1 and V2. I'll kind of hand it over maybe to Spencer if you want to talk about why what we saw with V2, where we saw there could be like improvements, what we've added into Baal V3, and how that process is coming along.
Yeah, cool. So I think what I'll do is I'll just kind of describe one way to think about Baal or MolochV3, and then we can kind of take it from there. I think there's probably a lot of different ways to think about the improvements, or like why it's necessary, or what it changes. But one way that I really like to think about it is that it's basically taking the concept of a Moloch DAO and expanding that to like all of the different, or creating more options for more changes over the course of a DAO's life cycle or life. So if we think about Moloch V2, Deacon talked about the proposals and the proposal periods and the grace period and some other parameters that are related. In Moloch V2 today, those are static. So once you summon your DAO, you're basically stuck with those parameters. You can migrate to another DAO and change those parameters and change a little bit of the way that your DAO works, but that requires moving to a different smart contract, moving all your funds, migrating your members, et cetera, et cetera. So there's some coordination challenges with that. Instead, one thing that Baal does differently is it allows the DAO itself, via a standard proposal process, to upgrade or change itself. So a Baal contract, a Baal DAO can change the proposal periods that it uses, or change some other parameters. So that is kind of one thing in the middle of the life cycle. It's giving a lot more flexibility to a DAO to change a little bit of how it operates.
And I guess
at the beginning,
Spencer, one thing I kind of forgot to go into is the minion. It might be good just.
Oh yeah, that's context. A good. Yeah, start there. Go ahead.
So the minion was kind of our. So one of the things that MolochV2 can't do is execute functions from another contract. The V2 contract had a lot of security kind of built in, and so being able to execute from another contract, which could, all different kinds of things can happen when you're running contracts. That was totally left out, but it's also something that is super powerful, right? So if you have your treasury of WETH and you wanted to swap it on an AMM, or you wanted to go buy an NFT, or you wanted to disperse it to 50 different people, or whatever you wanted to do, you would have to interact with another smart contract. So this is when we added the idea of Minion, which actually RaidGuild built the first version of that. And it was like, it's basically tied to a proposals state. So this is an external contract that's not linked to the DAO in any way, except for that external contract is reading the state of the DAO contract. So if you make a proposal through the minion saying, I want to execute this transaction, the DAO contract is used primarily just for the people to vote on if it should be executed or not. If the vote goes through as yes, then the minion will execute the transaction that you saved in it. If it's voted no, it can't execute it. So that was kind of our first step to being like, okay, how do we start integrating the DAO out into the greater ecosystem? And the minion evolved over time too, and now it's actually built in as a Gnosis safe. So the minion is actually a Gnosis safe with a little kind of contract shim in between the safe and the DAO, which does that same thing. So it still just looks at the state of a proposal and then executes something in the safe if it's okay. So that's just kind of how the minion works. And that's all I got on that, Spence.
Cool. Yeah. So we'll come back to why that's important for Baal in a second. But continuing the life cycle stuff. So I was talking about how in the middle of a DAO's life cycle, it might realize that it would be better off with different parameters, mostly relating to its proposal periods and the way proposals work. At the beginning of its life, the way that MolochV2 DAOs work today is you either have one summoner who kind of summons the DAO and sort of starts to initiate it and invites new people in, and they make proposals and they get voted in, or they can do it kind of like all at once with the multi-summoner. Multi-summoner basically allows a single person to add a bunch of people, basically an array of addresses and share amounts, and then all at once on summoning, those people will be members of the DAO. Baal extends that concept and makes it much more flexible. So Baal introduces, and to do that, it introduces this concept of a shaman. If you're familiar with Gnosis safe architecture, a shaman is sort of akin to a module, where in a Gnosis safe, a module can basically have full control over everything that happens in the safe. A shaman is kind of like that, but not quite. It's a little bit more constrained. But a shaman can grant or change a single or multiple, but one at a time. A shaman can change members' shares and loot amounts without going through the proposal process. So this is really, really valuable at the start of a DAO, for example, the start of a DAO's life. So for one example of that is if there's like a big kind of influx of funding and lots of people want to join the DAO at once. So kind of how Juicebox works today or Mirror fundraising works, where people just yeet a bunch of money into a contract and they get tokens as a result. A shaman could be configured to do a similar kind of thing, but instead of people getting tokens, what they get is Baal shares or maybe Baal loot. And then instead of having to trust the multi-sig signers with all those funds, they actually maintain rage quitability over the funds that they put into the DAO. So that's one example of a way to use a shaman. There's many others that I'm sure we'll have a bunch of people in the community exploring. So if that might be an area of interest for and a path for some of you guys to contribute to the Baal ecosystem, is to experiment with some interesting shamans that control directly shares and loot. So shamans, just like modules in the Gnosis safe, they're whitelisted by the DAO. So that's how the DAO maintains its security, by whitelisting only shamans that it actually wants and are vetted by the DAO. The other piece here is that towards the end of, or later on in a DAO's life cycle, well, in a MolochV2, the DAO kind of just continues on as it is. But we know that DAOs change quite a lot over time, and some of them, they want to stay as a relatively small community, and that's great. But some may have visions or aspirations of growing quite larger. And when you start to grow quite much larger, the completely permissioned membership of a Moloch DAO may, for some DAOs, be a little bit of a constraint. So what Baal does is it actually takes the concept of shares and tokenizes them. So in Baal, shares are ERC20 tokens. In MolochV2, shares are just kind of like integer entities that are in storage in the MolochV2 contract. In Baal, it's actually a fully compliant or token that fully conforms to the ERC20 standard. So if you're a member of a Baal DAO, you would see your DAO shares as tokens in whatever wallet you're using, or on Etherscan or BlockScout or whatever Explorer. The DAO, though, has complete control over the transferability of those tokens. So most DAOs will likely want to turn off transferability to start with, so that they can have the typical permission membership kind of thing for that's common to Moloch DAOs. But then over time, as they mature, as the culture sort of hardens, and they're able to open up to a more permissionless model, then the DAO can, via a proposal, decide to turn on transferability for shares, and then members can transfer their shares to other people and bring in new members in a much more permissionless way. And the same thing goes for loot. Loot is not quite an ERC20, but it is a kind of you can think of it kind of like a pseudo token. It is also 18 decimal places, just like shares and any other ERC20 token. It can be on approval from the DAO, or on the DAO deciding to make it transferable. Loot can be transferable as well. It won't show up in wallets and block explorers, etc., because it's not an ERC20 token exactly itself, but it has very similar kind of properties as shares in that sense. So one way, to recap, MolochV3 or Baal extends the possibilities that a DAO has at the beginning of its life cycle, in the middle, and also as it matures towards the end of its life cycle. There's a whole bunch of other stuff as well that's in here, but that's kind of one way that I think about the reason that we wanted to build Baal and make improvements on MolochV2. There's a few other things that we should probably hit, but I'll pause there in case anybody has questions or additional comments from Deacon or Isaac, maybe.
Hey, quick question. You mentioned that one of the big improvements in Baal is basically the tokenization of shares, essentially. Is that fundamentally like a scalability concern with the contract, or is it more of a flexibility kind of thing? Like, is it motivated more by kind of a technical challenge, or is it just extending the possibilities of what's available with Baal?
I think it's really just to make it more flexible. There's really, when you think of the Baal contract, what it is it's a mix of MolochV2 minions and the compound token. So there's, like, if anyone was in the GTC drop or the ENS drop, they use the compound token, and it has this idea of delegation, which Baal also has. So basically, we wanted to be able to replicate that model of governance and kind of a larger permissionless, I guess, permissionlessness, but still have rage quit. So it still has the idea of rage quit, plus a couple other little nice things. So yeah, I think it's really just for flexibility.
Gotcha. Thank you.
Yeah, so the DAO can choose non-transferable shares, which makes a lot of sense for a lot of reasons. or something more like coin voting and delegation, like the other ones.
Even when the shares, I'll add, even when the shares are non-transferable, they can still be delegated to other members of the DAO. I personally don't have a great anticipation for like how exactly DAOs will use that, but it's just another example of more flexible kind of governance models, all from a single DAO structure. So DAOs can kind of experiment with what works for them, or individual members can experiment with what works for them and what works best for their DAO. Let's see. I think the other big thing that we haven't touched yet is calling back to the minion concept. So just as a recap, in MolochV2, in order to interact with outside external contracts or other protocols that are outside of the Moloch contract itself, a Moloch DAO needs a minion to kind of help it do that. In Baal, though, we basically brought the minion functionality, the ability to interact with external contracts inside of the Baal contract itself. So now you can do standard Baal proposals that interact with and take advantage of functionality of other smart contracts, other protocols, other apps. And now we are able to, inside of one of those proposals, we're able to stack multiple actions together through multi-send or multi-call. So a single proposal, for example, can approve Uniswap to spend the DAO's token, then swap that token for another token on Uniswap, then do something with the resulting token in, say, Compound, then do something like a whole bunch of stacked together DeFi actions or other protocol actions all in one atomically. So a lot of DAOs today using MolochV2 and minions, they kind of have to get clever and stack those together with separate proposals and try to vote on them like all in sequence. But with using multi-call, we can actually stack them together atomically, reducing the governance overhead quite a lot of taking some of those actions as a DAO.
Yeah, and so multi-call is now on the safe minions just this last week, I think. So kind of in alpha testing, but the other really cool thing about minions is this kind of idea of a rage quittable main treasury in the DAO and a non-rage quittable side vault, because there's different use cases in different DAOs. Like working capital may be dedicated to some stream or some task, and once that's kind of earmarked there, then it's been voted on by the DAO. It probably shouldn't be rage quittable. They've kind of decided that that's how it should be spent. So having multiple treasuries and having one treasury rage quittable and some not rage quittable is important. The Baal will kind of have all that built in, even in its own treasury, but it'll also be able to have minions as well. So it'll be able to we'll be able to compose all the things that we've done in the past and you know have multiple things going on. But Spencer, did you want to keep going on some stuff, or do you think we should get into some code?
Yeah, I think we hit all the big topics. So yeah, let's get in the code.
And unless, does anyone else have any more questions? Cool. Isaac, I don't know if you would want to share your screen.
Sure. Yeah, should I just I can walk through the contract and the tests?
Yeah.
Cool. So here we have Baal, and let me post the link to this in cohort chat so that you can all follow along if you'd like. So it's probably a pretty daunting contract to look at from the beginning, but we are very meticulous about commenting. I think every single line, struct, function, parameter is called out. So the there's some interesting ways that this contract is structured. One is how it is summoned and set up. So you'll find if you start digging through here, there's a lot of like ABI encoding and ABI decoding. This is kind of a trick for if you've ever encountered like call stack too deep and stuff like that, like, or if you encounter issues where you need to like have a ton of local variables based on the parameters that you're passing into a function. Sometimes what you can do is like encode all of that stuff into like one concatenated bytes array, and then like decode that if and where relevant within the function. So let's see. Why don't I actually go through how submitting a proposal works? So submitting a proposal, we have this function here where we have like the person specifies the voting period, the proposal data, and the details. So you'll notice that this like proposal data is just this one bytes array, and the contract then actually needs to know what to do with that, because it's actually like a concatenated string of all the different actions that the member wants to effect. So let's see, I'm trying to think of the best entry point, because there's like, this is a pretty complex contract. Should I maybe like go through like walk through the test file? Maybe that would be useful.
Yeah.
So just some info on like the setup here, the development test suite. This is like my go-to development suite stack that I've compiled from a bunch of different projects I've done. So this uses Hardhat. It specifically uses like a TypeScript flavor of Hardhat, so the Hardhat configuration files.ts. Also feel free to like chime in at any point if people have questions about like the frameworks or plugins and stuff. But the nice thing about this test suite or this development suite is that as we develop the Baal contract and we compile it, it uses typechain to automatically generate TypeScript typings, so that when we're writing our tests, it's a lot easier to know the parameters and stuff that we need to use. So if we look at the test file, the first thing that we do is we deploy a Baal and call all of the setup functions. So the setup involves specifying all of the different settings for the DAO, because different DAOs might have different options for what their voting periods are intended to be, what their grace periods are intended to be, whether loot can be transferred, whether shares can be transferred, what are the initial shares that need to be given to the summoners, and in addition, what's the loot that needs to be given to the initial summoning members. So all of that stuff gets configured on setup and encoded into this like long bytes array. So all of these initialization parameters get passed into Baal, which Baal then uses to call all of these different setup functions on itself. These functions are actually the same functions that we then later use for proposals, for doing things like adjusting the internal settings. Let's see. I know that it's kind of a lot to dive into. Is any of this resonating, or are there any specific parts that people might be interested in exploring more?
I think this is great, and maybe we could just go into summoning first, because that's kind of like how we set up all the different starting states of a DAO, and I think that could be good. Just talking about the parameters and you know.
Yep. There's also some fun stuff that might be able to share as well, because we like to add a lot of Easter eggs into the code. So we can look at that in a moment. So summoning involves setting up all of the different configuration settings. So if we look at baal.test.ts, we can see what the summoning procedure looks like. So first I deploy a version of Baal, and then what I need to do is call the setup function. This deployment pattern, it makes it really easy to create factory contracts where you can deploy a singleton and then deploy this proxy pattern where it's not like an upgradable proxy where you can swap out the implementation, but you pretty much only have to deploy the logic once, and then you can deploy a bunch of clone contracts which just delegate all of their logic to the singleton. So if you're doing a really big expensive contract like Baal to deploy, this is a good pattern to use, because then you only have to do that big expensive deploy once, and then every proxy deploy is actually really cheap, well, comparatively. So what are the different parameters that you want to use on setup? We want to set what the minimum and maximum voting periods are, what our grace period is, and the loot and share settings. We want to set what the tokens are that our bank should be able to manage. In this case, I'm only including WETH. In this test suite, it's like a local version of WETH that I have deployed. A shaman, we have one shaman set up on deploy. I'm not sure yet if it will be common for people to have a shaman already deployed. I think that it might be a useful thing to have at the beginning, depending on how people are onboarding to the DAO. Because you might not, as in the early days of the DAO, you probably don't want people to have to go through all of these voting periods to get their shares. You might just have anyone that meets these qualifications can claim some shares, and that's what the shaman would allow them to do. We also have our initial shares. So in this case, we're just minting some shares to the initial summoner, and we're also minting some loot to the initial summoner. But this can be an array of however many people need to receive shares and loot right from the beginning. We also have to call delegate summoners. What this does is basically it makes it so that summoners, all the summoner shares are delegated to the shareholders. But what we could also do instead is maybe when people might want to delegate right from the beginning, there's shares going to 5 people, but they all want to delegate to the same one person. We could have that configurable right in the beginning. Does that make sense so far? Multi-action is a really cool pattern. So Gnosis has this library that's deployed on every chain called multisend, and it looks intimidating. It's full of assembly, but what this allows you to do is pack a bunch of transactions together and iterate through them and execute them all one after another in a very gas efficient way. So after all of these functions are set up to set the initial parameters, it then does an additional encoding step where it calls all of these functions through the multisend library. So in Solidity, the way that library contracts can work is that this is a singleton that's deployed only one instance per chain, and then any contract that wants to use it can delegate call into it and leverage its logic. It's the same way that proxy pattern works that I was talking about a moment ago. Cool. So we do a setup, and then what happens in this test file is that for every single test that we run, it summons a new Baal, sets up the initial parameters, and then run through some test cases. So any questions jumping out from folks on summoning any of the utilities or any of the patterns I mentioned? Cool. So we also have I mentioned the proposals. Proposals, we encode the actions in the same way. So if we're going to have any proposals that want to either mint new shares for somebody or mint new loot for somebody, or even call out to any arbitrary external contract, that can all be encoded inside of proposal data. And then if this proposal is successful, and to be successful, it has to first be sponsored by a member, and then it has to be voted on for at least the minimum voting period, and then we have to wait for the grace period, and then finally the proposal can be processed. And so down here in this process proposal, it takes that packed proposal data and it unpacks it, and then it iterates through and executes all of those calls using the multi-send library. So this is kind of an interesting pattern that we developed during Minion development that we're also using here in Baal. You see all of these functions that are marked external Baal only. These are like the internal configuration functions and that adjust like shares and loot and everything like that. We want to be able to chain all of these actions together without having to replicate all of that like multi-sending and looping code. So even though these are marked external, the calls are actually coming from this contract itself. So it's this contract doing a delegate call to multi-send, which calls back into this contract. And that allows us to have these like chainable configuration functions. There's also some fun stuff in here regarding like SVG NFTs. So if the folks here are familiar with like what loot NFTs look like, it's just these SVGs which just use string concatenation to piece together a few different like items based on a randomness seed. So we wanted to have. We've been playing a lot in DAO House with the idea of these like dynamic SVG NFTs. So we also added this interface of token URI to Baal, where any member can have their shares not only represented as ERC20 tokens, but as like a dynamically generated SVG NFT. So I want to try to find an example of what one of those looks like.
Yeah, what's kind of interesting about this is, there's these different interfaces for ERC20, ERC721, and we're just taking, just exposing that interface so that wallets can read it, basically, or NFT marketplaces on your profile page. So yeah, it's like, it's a non-transferable NFT if you own the token. It's kind of a cool little thing. So it's like, it's going to show you how many shares and how much loot you have. And we've had, it can be as simple as like what loot NFTs look like. We've also done some other things where we've added some different colors and different designs and different shapes and stuff. Yeah.
I think here's some like different fun versions, but to me, like this is what this gets at is like I think actually a pretty important point about like ERC standards and Solidity development is that while ERC 721 tokens are generally like a static thing where it's a token URI, ideally it points to something like decentralized, like an IPFS or Arweave location, but oftentimes it points to like an S3 URL or something. What you can also do is just add all this more complex logic into token URI. Because token URI is never called like I can't imagine like almost any scenario where token URI is actually called on chain where it's actually costing gas. So you can all of the optimization stuff that you have to do in Solidity for gas and not wanting to loop and not wanting to piece things together, you can do all of that within a token URI function because it's only called as a view, and so you're never actually spending gas to call it. So something that we've been playing around a lot is like, can these update over time? Where, if you're a member today, it says 100 shares, 500 loot, but what if like you quit and now like a new like PNG can actually get layered into this SVG, which shows like, I don't know, some flames that show like, all right, this person quit. Just all sorts of like different fun things that you can do. When you start thinking about ERC20 standards, more like a standard for like API interfaces rather than like static tokens. You can start creating all these like different kinds of fun interfaces and experiences. So good to have fun with your Solidity as well.
Yeah, the one thing it does increase is your deploy cost, but if using that proxy pattern, that's going to help a lot if you're deploying a lot of them. The template cloning pattern. But yeah, you're adding a lot more code into your deployment when you're layering in all this string stuff with an SVG. So there's still some limitations, but another cool thing that we found is that SVGs can load images. So you can throw an image up on IPFS and then load inside the SVG just that content hash, and it'll load that. So you could theoretically with that do some kind of generative PFP kind of thing if you wanted, but
you could have the layering of all this stuff be actually dynamic instead of just kind of done ahead of time and then like uploaded on a CDN. Yeah, so that's kind of the state of Baal development. There's quite a lot of like in-depth facility stuff to read into, but just wanted to open up the floor to some folks that might have questions about certain development patterns or like utilities that I've been talking about today.
I have a question. Can you show where do you actually use, for example, the chaining that you were talking about?
Yeah, so if we look at the test file, code multi-action. So here's one place where it's used on setup, but it's the exact same encoding when it's in a proposal. So I have this encode. So first we encode all of these different calls using this like ethers utility. So ball.interface.encode function data, and then you specify the ABI of the call you want to do. And what this gives you is like hex encoded calls. So these are just strings of like hex encoded data. And then what you can do is do encode multi-action, which is a delegate call to the multisend library. And we say, and so here's the array of all of the different actions that we want to do, the targets for all of those different actions. So in this case, all of the targets are Baal itself. But you can imagine that this could be, 6 different calls to transfer 6 different ERC20s, or like complex things like, chaining a flash loan together with other stuff, or like you can any type of like multi like some of the more complex multi actions that we've done recently is we've been doing this experiment with the Metafactory iRobot DAO, where we're actually like approving ERC20s and putting them into like an LP pool, like a balancer pool, and then moving the resulting tokens like to another place, all in one proposal. And that makes it so that you can save a lot of time by having like proposals have like many like complex interactions rather than just one action per proposal.
Okay, got it. Thanks.
The kind of interesting pattern here is that we combine all these transactions into this one big encoded multi-action. Could be a really huge hex value then, and then we just pass that in as call data and emit it into an event and hash that into something that we save on the contract. So that ends up saving space because we're not saving all the transactions that are happening. We're just emitting them into an event. And then when we go to actually execute it and process the proposal, we're taking that hash that we saved, just a normal hash, and pulling up from the events what the actual transaction hash is, and then executing that. So that saves a lot of space, storage in the local contract.
Yeah, like another I guess Solidity pro tip is like quick estimating gas costs. I think that correct me if my information is outdated, but I'm pretty sure like every time you call like the store opcode, which is called every time you assign something to a storage variable, costs you about 20,000 gas. So you can actually kind of do some back of the envelope, like 20,000 gas times, like, let's say it's 100 times 10 to the, like 100 Gwei, which is 100 times 10 to the minus 9. So every time you're storing something, just one like UN256, it's costing you like 0.002 ETH, like with average gas prices. And like, of course, I haven't looked at ETH prices today, but like, like that adds up. Like so you can think about every time you're doing some sort of storage, you're costing someone like $8-9 per transaction. So as much as you can, avoiding storing things and just emitting things when possible. Because I think an event costs 500 gas, so pretty big difference, or even less.
Is there
Yeah,
a
speak up.
specific name for the pattern? Sorry, I think my mic was on full. You had said it's not the upgradable proxy, but you kind of referred to it as a proxy kind of pattern. Is there a specific name? Or
It might be under, it might be EIP 1167, and then like Gnosis has their own like flavor, which I like to use their libraries. Sometimes like they have got this this like factory friendly pattern, but I think EIP 1167 is one implementation of it where you can deploy basically a singleton template, and then like there's not a whole lot of useful info in this specifically, but if you look at some of the other repos like Minion Summoner v2, you can see what that pattern looks like in practice. Yeah.
for the examples.
Yep. So here's like a summoner. So you actually have to deploy 2 contracts in the beginning. You deploy your singleton, which is the logic template, and then you deploy a summoner, which is like your clone factory. I just did like a live generation of an SVG NFT so we can decode this and see what this looks like. But yeah, you can just kind of see how the base 64 data that comes out of that token URI ends up being like a layered SVG with your shares and stuff.
Yeah, and so we're coming up to the end of the hour. I guess the last thing we want to just point out is that, you know, Baal is still in development. We had a UX review today and a few things came up. There's still a lot of issues. There's a lot of things, tests, documentation, solidity work, that if you want to contribute to this initiative, there's space for it. And
yes.
You know, reviews and audits and all these things are coming up. So if any of this seems fun and interesting, definitely you can reach out to us. There's a working group in the Meta Cartel Discord, and a repo called Moloch Mystics on GitHub. That's where the Baal contract is. That's where you could check out and start getting involved. And yeah, just we're kind of getting to the point where we're getting closer to where we can kind of lock it down and get into the kind of more audits and optimizations kind of stage. Probably looking like early next year that we'll be able to get this like really out in a production sense. But we've been deploying it on test nets and side chains and playing with it a little bit. So, but there's still a lot of changes to come.
Yes, lots and lots of like I've been filing just issues to keep track of improvements that we've been coming up in sessions. So if you want to learn more about like tests, build like test coverage, or even like core things that like bug fixes or optimizations, there's quite a lot of stuff if you want to kind of jump in and do some and start contributing. So yeah.
Cool. Time's up. Thanks a lot, guys, for coming. And you can always hit us up and get involved in that channel if you want. And we'll talk to you again soon.
Thanks, guys.
Thanks so
Thanks,
much.
everybody. Thanks a lot, guys.
Which channel was that?
Thank you.
In cohort chat, I put a link to the channel on the Meta Cartel server.
It may
Oh,
be
okay.
it may be closed off, but if you want to get
I think it's public now again.
okay, cool.